In this video I'm going to take a look at ionic equations. So what we're going to do is turn this chemical equation here into the ionic equation. And basically, in a nutshell, all an ionic equation involves are the species that change in the reaction. So I'll put some water into these two beakers. The left-hand beaker represents what we've got at the start of the reaction, and the right-hand beaker represents the products. So what have we got here? Well, we've got 1 mole of H2SO4, but the important thing is that it's aqueous. So any aqueous substance you've got in your equation, you must break it into its ions. So what have we got in a mole of sulfuric acid? We've got 2 H plus ions. So I'm going to write H plus twice in this beaker. Just put them anywhere in the beaker. What we haven't got, and what I see sometimes from my students, is this here, H2 with a 1 plus charge. So there's no such thing as that, okay? I can see why a student would write it because you've got H2 in the formula, but that is not the hydrogen ion, it's H plus, and we've got 2 separate H plus ions in the solution. Okay, the next thing we've got is a sulfate ion. So this polyatomic ion, don't separate it into sulfur and oxygen. Keep it as a thing, as a single thing. So SO4 2 minus. Right, so if we move on to this substance here, so we've got potassium carbonate, and that's made from 2 potassium ions. So they're K plus each. So 2 of those, and we've also got this polyatomic ion, so it's not a separate carbon and 3 oxygens, it's a CO3 2 minus ion, so just pop that somewhere as well, CO3 2 minus AQ. So hopefully this visualization will help you to appreciate what's actually here. So if we move on to the products now, we've got another aqueous substance, we've got to show the ions. So again, we've got 2K plus ions. So we'll pop them in the beaker, just pop them anywhere. And we've got a sulfate ion, 1 of those, just put that in. If we move on to the H2O, you'll notice the state symbol, it's not aqueous now, it's liquid. So the rule is, if it's a solid, liquid or a gas, we leave the formula as it is. So we're going to write H2O, L in that beaker, just for the visualization. And if you look, carbon dioxide is a gas, so we leave it as it is. So pop that in there as well. Obviously that would bubble out, wouldn't it? Right, so what we can do now is we can cancel out ions that haven't changed. We call them spectator ions. So you can see that we've got K plus, 2 of those in each beaker. So we'll cancel them out. And we've also got the sulfate ion as well. So what's left is going to be our ionic equation. So the ionic equation, I'll just make the pen a bit bigger so we can see it a bit better. So the ionic equation is H plus plus H plus, so 2H plus aqueous plus that carbonate ion, and that's made carbon dioxide gas and H2O liquid. Okay, so the rule again, if it's aqueous, show the ions. If it's a solid, liquid or a gas, leave it alone. Okay, so hopefully the visualization will help you make more sense of those. So we'll do one more. I've lost the beakers now. Do that so that we've got the full white screen. Okay, so this is a trickier one because obviously we've got more involved here. So let's have a look at this. So what have we got? We've got 2 moles of sodium phosphate. So think about what that's made from. It's aqueous, by the way, so we're going to have to show the ions. So we've got sodium ions, Na+, So there's 3 of them in one of those, but there's 2 moles in the equation. So we've actually got 6 Na plus ions aqueous. Okay? That 2, the balancing 2, doubles everything. So we've got 2 phosphate ions. So 2 PO4 3 minus AQ. So moving on to this now. So we've got 3 moles of calcium chloride. So we've got 3 Ca2 plus ions. Now the ion that makes up calcium chloride is the Cl minus ion, not Cl2 minus. So what have we got? Well, in one of those we've got 2 Cl minus ions, so in 3 moles we'll have 6. So plus 6 Cl minus AQ. Okay, so I'll move on to the next. I'll just drop down here. Products wise, we've got another aqueous substance, so showing the ions, 6 lots of sodium ions, 6 Na plus AQ, 6 Cl minus AQ, right, look, this is a solid, so I haven't seen a solid yet, so we'll leave it alone, Ca3, PO4, twice solid. Right, so let's cancel out the spectators. So what can we cancel? 6 sodium ions, they go, and the chloride ions go as well. So there is the ionic equation. What's left over is the ionic equation. So let's, I'll do it. 2 PO4 3 minus AQ plus 3 Ca2 plus AQ goes to Ca3 PO4 twice solid. So it's really important that you know your ions. I'm always stressing to my students how important that is. So you've got to know your ions, and just remember that simple rule: if it's aqueous, separate it out into ions. If it's solid, liquid or gas, leave it alone. And that's it. Hopefully that was helpful.